Okay, this is where we're going next. Well, sorta. Via the milling machine and the lathe. Which we're gonna do some stuff on there too here, just directly, as soon as I get all the pieces prepped. Anyway, this is power press I've been working on. I beefed up this section here, a decade ago, and put another piece up on top so I'd never blow this center section out. I think that'd just about be an impossibility now. The way this is all built up inside and everything. Anyway, I think those were air cylinders at one time. They're brass cylinders. I put them under a tremendous amount of pressure. I've got a gauge over here I'm going to install, and we're going to see just what kind of abuse that we're giving them things. But anyway, then we got a couple of hospital bed motors and a control box, pump box, adjustable deck. That's what the hospital motors are for. They got a little cable deal on them, you know, it goes down right, it goes into a slot like that. Yeah, pretty handy freaking deal. Lifts the deck up and down, and I can control one side, left or right, whatever I want to do. And then I made big 1-inch stainless steel pins on each side. Hey, if you're not in the habit already, start unplugging your grinders and stuff before you try to change the wheel. You know, and I'm old enough to know better. And I looked right at the cord about the time I grabbed that wheel and said to myself, I should unplug that. And I grabbed a hold of that wheel before I unplugged it, and it bit me. So, strong suggestion, guys. No matter how good you are, or how good you think you are, unplug that stuff. Shorter, we need to choke up. There we go. Right? Okay, I think I've got what I wanted for down here on the corner. We just need a relief cut, you know? We want it nice and straight though, okay? And I set that in the profile, and I really like the looks of that. So that's what we're gonna run. It's an older bit, it's double Indo. Boy, I wish I had a box of these. It is. See? Clean the deck. I just don't want to write. Used chunk of iron, just dug around in the shed till I found something, you know, and then cleaned it up. You know, if you're in a hurry, I wouldn't suggest doing it this way, but we want 12 inches out of this because that's what our bending plate is. I don't put that back there to make it hard for me to get out. I put that back there to make it hard for somebody else to get out. Okay, guys. I can't spend too much time on this. I'm 3 weeks behind and I've only been working on the project 2 weeks. I need to address this and be more clear about it than I was before in the previous video. Pierre brought something up the other day and I addressed his comment, but I didn't clarify what he was talking about. What Pierre was talking about was this. This is just inverted angle iron, right? Both these pieces are just inverted angle irons, right? I just flipped them upside down, and you can do the same if you're trying to build a cheap upper die or lower die to do bending, like in one of them hand deals or hand operated presses that you get from Harbor Freight or anything. Why anybody would run a hand operated one, I don't know, because you can get an air operated 20-ton hydraulic jack. It's air over hydraulics. That was what I was in the military working on, was pneudraulics, they called it in the military. It was pneumatics, which is air, over hydraulic. And we were working on F-15s and T-38 trainers in those days. This is clear back in the 70s, you know. F-15s, do they even use F-15s anymore with all the stealth fighters and the invisible stuff? I don't know. Anyways, it doesn't matter. If you want to comment, if you're up on that and you want to comment without getting yourself thrown in military prison by letting out, you know, military secrets, you know, you can tell us what they're using nowadays instead of the old F-15s. But anyways, back to what Pierre said. Holy cow, do I get distracted. Anyways, angle iron is just that. It's angle iron. And it's supposed to be somewhat close to 90 degrees. Because of the nature of what, you know, back to what it is, what they use it for, it doesn't have to be perfect 90 degrees. And this is what Pierre was talking about. I put a piece in here and was machining a 90 in the machine at an angle. And because of what I was using it for, it didn't have to be perfect. And I knew that. But I didn't convey that in my video. I just threw it up there and went to work on it. You can do that. But when you machine something using angle iron as your fixture, remember, it may or may not be a perfect 90 in here, because these may not be a perfect 90. So if you need something that's a perfect 90, you have to jig it or fixture it with things that are ground perfect 90s, you know. That way, you know, your piece will be a perfect 90, a perfect 45, or whatever you're after, whatever angle it is that you're after, then do that. You know, if you're looking for absolutes, for zeros. I ran a dial indicator across that, but that doesn't tell us whether it was 90 or not. So all that told us is how straight that line was that I machined. That's what I was after. I didn't want a bobble in my sheet metal anywhere that was noticeable, and I didn't want it bowed or anything like that. I wanted to make sure that that was my main concern on that particular piece, was that V groove that was in there was straight as I could make it here in my garage. But Pierre is right, and I don't want to be dismissive about, because he was being very constructive about his comment, and you guys need to know that if you use angle iron for your fixture, you can do that. Yes, you can do that, absolutely. However, check it to make sure that this is a 90-degree corner. And one of those carpenter squares, you know, and even a speed square, I would not, if I was after absolutes, dead on 90 degrees or whatever I'm after, I would not use a carpenter square of any kind. Swanson, I'm not supposed to say that. The speed squares, whoever the manufacturer is, or carpenter square, I would look at machined milling blocks. That 1, 2, 3 blocks are fantastic for that, because those are a ground block. Here's a rule of thumb. If you're just looking for something that gets you close, then use get you close type of jigging and fixturing. If you're looking for absolute machining, zero tolerance, then use zero tolerance fixtures and jigging. Okay, that's your rule of thumb. You know, without me going on and on, there's your rule of thumb. If you want close enough, then use close enough. If you need absolute, then use absolute. Okay, let's get on with the rest of what we're supposed to be doing today. All right? What I want to do is mill a 90 on the end of this piece right here. I got this thing adjusted right? Yeah, okay, that's pretty good. I want to mill a 90 on the end of this piece right here, so I got to have a way to hold it. Can we hold it the same way we did the other piece? The other piece was a lot bigger and we were doing a different job on it. Can we use the same fixture again? I think so. I think it's the same job. You might have to provide different tooling. I hope not, because I like that other tool. But you might have to use a different tool or a different fixture or something to get down to it. I don't think so. I think we're going to be all right. They're the same length. You know, there's the same length of piece. This one's just a lot narrower. But if we can do that and make a mate to go down into that groove, now we've got a brand new, what's the word for the top piece? Do you call that the punch? Even though when it's a die situation like that, what would you call that piece? You know, I'm for lack of terms, but what I do, I wander off. My friggin' clamp grew legs. Now we gotta go hunt him down. How would that happen? Somebody's getting a little overzealous in their cleaning, I think. At station 2, we're trying to do this. Okay? To hold round items in here. I've got 2 for sure, these pieces that I need to work on. So it's worth building a fixture to me, long as it doesn't get too time consuming, and can I use it again later? You got to know the sequence in which you need the components. Instead of starting on a component that's not needed yet, until, you know, there's no way that you can use that component until these other three pieces are done, then there's no need to work on that. You can start setting up on it, as long as that setup doesn't interfere with any of the other components that comes before it. That's how I look at it. It's workflow in the shop. There's a sequence in which these pieces have to be done, or it'll take you 6 months to do all this because you keep getting in your own way. It's a workflow thing. You got to think about what needs to be used first and work on those pieces. I gotta go change batteries, but I'm gonna throw in a parallel. I measured the parallel. It's an old one. It's within about a half a thousandths, which is plenty good for this type of project that we're doing. I didn't like the way it sat down against the weld in between our two angles, you know, so we're going to clamp it there. No need to clamp the parallel. I'll just block it with this other one. Looks like that other one's in the way, so it, you know, it can't rattle out of there. It's a little more in line with this support right here. So that's where it's cutting. If you see now, we're more in line with our main support instead of being out here in the open. I'm liking that a lot better. And you can tell by the finish that the cutter head's liking that a lot more too. It's not groaning as much. We'll let you guys do this cut here. I gotta go over here and do this, so keep an eye on this machine. So I'm gonna do this other video. Appreciate you guys helping out. I do need my roller. You guys gotta provide your own roller. Finishing that cut. As soon as it gets done finishing that cut, we'll restart the mill and jump over to the lathe. We'll leave these over at the mill because we're going to touch these up. Alright, the milling machine's almost done. Let's go do a reset on it. I'm going to leave you guys right where you're at. You don't need to come over there and help me do that. I'll reset the mill and we're going to head on back to the lathe. I'll leave these two pieces over in the mill. Okay? They're about 1.25 inches wide, right? Stick that out there on the edge and read where I'm at on top, right? We got about a 16th to go. About 60 to 70 thousandths to move this point right here over. About 60 or 70. Then we'll flip the piece over, and even if we go over a little bit on this cut, we can compensate for it by, you know, centering everything up from the other side. That'll be our final side. We don't want to flip more than once. That's it. Flip once, do it right first time. Let's see if we can do it, guys. We got lathe work to do. Let's get on over there. Back over to the mill, reset it, come back, do this. Okay? You gotta stay busy. You gotta stay busy or you don't get to have a machine shop. Somebody will take it away from you. Alright. Where'd I leave the ruler? You know, the regular steel ruler, not the block one. The other one. Here we go. That'll just drive a guy crazy. Right where I quit working. But I gotta have all this stuff. For right now. You know? Let's get this piece tied down and send it. I got to get back over on the lathe. We got waylaid looking for, it's Thursday. I mean, you got to start tapering off, man. It's Thursday. I mean, it's Thursday, Thursday afternoon again. You know, so you got to taper off, man. Holy cow, I wish we would have got more done today. It's 4:30 now. How are we going to taper off if we keep working like this? Anyway, I'm going to tie this down. I'm going to send it down that piece because we're going to finish that piece tonight before we get out of here. And the piece is in the lathe over there. I'd like to try to weld one of them together and set it in the machine over here with my other new jigging for the vise before it was over. Let's see what we can do. You know, I mean, it's 4:30. Boy, we can't stand around and BS, can we? All right, get to work. We're getting some parts gathered up here that need working. Those two rails got to go on this plate after we're done welding this jig all together here, so we can do our quick exchange things over there. And we got a few more passes to make on our bending die. So we're trying to do all of this at once. But what are we held up with? Remember I said I was gonna get over here and clean these pieces iron up? Well, yeah, we run around doing all the fun stuff, and now we gotta do this. No, you can't cop out because it's not even 6 o'clock yet. You know, can't quit. I know it's Thursday. Get back to work.